Okay, good afternoon. In the subject of heat and mass transfer, today we are going to see another experiment, a determination of Stefan Boltzmann constant. So here we are going to calculate the Stefan Boltzmann constant value in this experiment. So let's start today's video. So in theory, the basic theory of radiation and Stefan Boltzmann's law. So we know that each and every material, every body, every particle emit the radiation which having more than absolute zero temperature. And so we know that the Stefan Boltzmann's law, which said that the emissivity of any surface is proportional to the fourth power of its absolute surface temperature. And remember, I always said that whenever it is a topic of a radiation, we have to keep the temperature in Kelvin only. Okay, so absolute zero temperature means 0 Kelvin. It is not a 0 degree centigrade, it is a 0 Kelvin. So the body which is above absolute zero temperature, it emits radiation, and that radiation is directly proportional to the temperature raised to the power 4. If we simplify this, remove the proportionality sign, so your emissivity of that surface will be equals to sigma surface area emissivity and temperature raised to the power 4. So emissive power of any surface, if we are considering emissive power of a black body, so we know that for a black body emissivity is equals to 1. So for black body it is equals to 1. For other surface, emissive power is equals to sigma Stefan Boltzmann constant multiplied by surface area available for radiation, its emissivity, and temperature raised to the power 4. So according to Stefan Boltzmann's law, emissive power of any body is directly proportional to temperature raised to the power 4. For any body other than black body, if black body is there, then emissivity, this term will be removed out because it is equals to 1. For any body, emissive power will be sigma multiplied by its surface area available for radiation, emissivity of that particular surface, and temperature raised to the power 4, and that temperature will be the absolute temperature. So for black body where emissivity is 1, so our equation is get changed to EB, that is emissive power of a black body is equals to sigma surface area temperature raised to the power 4. What is the standard value? Standard value for Stefan Boltzmann constant, it is 5.667 into 10 to the power minus 8 watt per meter square Kelvin. No doubt, exact same value is not possible on our experimental setup. If it comes, then it is just luck by chance. But in actual, our experimental setup is not that much highly calibrated, and the conditions are not that much standard condition we are performing our experiment there. So it is expected our Stefan Boltzmann constant value nearby 5 plus minus, but 10 raised to power minus 8 should be there. So your value might become like 4.5 into 10 raised to power 8, or 5.5 10 raised to power 8, 5.8 10 raised to power 8. So it is accepted because it is a non-standard working condition, non-standard equipment, highly calibrated devices, thermocouples. So it is accepted, that is, it will be within some range. So our final answer, our finding should be in the range of 4.8 to 6 into 10 to the power minus 8 watt per meter square Kelvin. Then we will consider our experiment is successfully completed and the value is nearby the actual standard value. Now, what is our setup? So this is a schematic of our experimental setup, where there is a one top, over the top there is one heating tank is there. In this heating tank, one thermocouple is always inserted in this water, and there is one electric heater is provided. When we switch off our electric heater, so heat will be dissipated and this water will boil, or its temperature get rises. So we have to rise the temperature of this tank water at least 90 degrees centigrade, 90 to 100 any temperature. This temperature will be shown by thermocouple T6. So we have to check the T6 knob, where it is going to show what is the exact water temperature at that particular water tank. Once your water get heated, suppose it is heated to 90 degrees centigrade, then with the help of this knob, allow this hot water to flow into this hemisphere. Now in this hemisphere, there is internal hemisphere. From inner side, it is coated with lamp black. And this hemisphere having 4 thermocouple, T1, T2, T3, T4, randomly mounted. When we allow this hot water to flow, then this hot water will flow into this hemisphere outer side and it will fill. So as it is going to fill, your water level will be rise in water level indicator. So we have to monitor whether it is filled or not. We have to allow this water till this hemisphere get completely filled. How it ensure that it is filled? So there is a one overflow hole is there on this hemisphere body outer shell. When water completely filled, then through this overflow, water will escape. That time we have to close this knob. When we close this knob, that means this hemisphere is completely filled with hot water. This hot water provide heat to this black coated inner hemisphere, and with the help of temperature knob, we can check out what is the temperature of T1, T2, T3, T4. So we have to measure 4 temperatures, T1, T2, T3 and T4. When we make an average of these 4 temperature, it become a hemisphere temperature, average temperature of this hemisphere. This is the first part of our experiment. In second part, once we note down all these 4 temperatures, there is another one thermocouple which is mounted on test disc, and this test disc is hang at the bottom side of this hemisphere, and at the bottom side there is one drill hole. Unless we insert this test disc, this is a wooden block, and on this wooden block there is one metal copper disc is there, and on that disc there is a 5th thermocouple is mounted. Unless we insert this test disc into this hemisphere, its temperature will be a room temperature. Once we note down all these 4 thermocouple readings, then after we note down T5 before inserting into hemisphere. So that is counted 00 second. What is the value of T5? And the instant when we insert this this test disc, so test disc is inserted in this hole. Now what happened? This test disc also coated with lamp black. Inner hemisphere get heated due to hot water. This lamp black body of inner sphere will radiate heat towards test disk. Test disk also lamp black, so it receive all this radiation and its temperature rises. So before inserting this test disk into this hemisphere, it having a different value of a temperature. As soon as we insert it, we have to start stopper, and after each 10 seconds we have to note down what is the T5 temperature. Before inserting, suppose it is 20 degrees centigrade. After inserting, we have to start our stopper, and after each 10 seconds we will monitor what is the value of T5. No doubt, as the time goes on, our test disk temperature will increase. So such that we have to note down 4 to 5 temperature for T5. And then after our experiment is over, we have to remove this test disk outside this insert hole. Then after, with the help of this drainage valve, we have to drain out all this hot water from this inner sphere, and we have to shut down our equipment. So this is a very small experiment, small process, small time required. Now let's see what is the experiment setup. So I just explained, there is a hemisphere. In hemisphere, inner hemisphere having a lamp black coating, having 4 thermocouples. Outer hemisphere and inner hemisphere, that angular gap is filled with hot water. Bottom of hemisphere having one drill hole where we have to insert that test disk. Test disk is mounted on a wooden block. The copper disk is there, and this disk is also lamp black, and a thermocouple T5 is mounted there. Safety precautions. So never on the heater before putting water in the water heating tank. That's why many times it is observed that student first switch on the experiment and then they observe, oh, that water is not poured into the water tank. So never do that. First pour the water into water tank sufficient level. That means your heating coil should be submerged in that water. Then switch on your heating system. And whenever you open the hot water flow into the hemisphere, so open it very gradually, because it is a very hot water, and quite possible that that drainage outlet, that drill hole is there. So many times it is observed that there will be a hot water flow in a high speed and it injure. So always open gradually. Now observations. What are the observations provided with this experiment? So mass of test disk, and it is already given in your manual. It is 0.002 kg. That is the mass of your test disk. Diameter of test disk is 25 mm. Along with area of test disk is provided. So in this case, don't go to calculate area of test disk by diameter. Okay, so area of test disk 4.9 into 10 to the power minus 4 meter square. Then specific heat of test disk material, it is given 0.41868 kilojoule per kg degree centigrade. Remember, the unit is kilojoule. Whenever we are going to put this value for any calculation purpose, we have to convert this into basic unit, and basic unit will be joule per kg degree centigrade, or even though joule per kg Kelvin. So when we put this value Cp of test disk material, so it will be 418.68 joule per kg Kelvin. So these are the observations are provided in manual. Now observation table. So this is our observation table. One part is for hemisphere, second part is for test disk. When we start to note down our readings. So we have to note down 4 thermocouple readings, that is T1, T2, T3, T4, which is mounted on hemisphere. So there is only once we have to note down these 4 thermocouple. Then before inserting test disk, that is 00 second, we have to note down the temperature of test disk, which is given by T5. And once it is inserted, our stopwatch also starts simultaneously, and after each 10 seconds we have to note down the change in test disk temperature. So 10, 20, 30, 40, 50, we are note down these T5 temperatures. Now the calculation parts. In calculation, first average temperature of hemisphere. How to calculate? So we have 4 thermocouple on our hemisphere. So make an average of that 4 temperatures. So it will be TH, hemisphere temperature, in degree centigrade, because the indicator is calibrated in degree centigrade. We have to convert into Kelvin. Next, test disk temperature. When it is said that test disk temperature T equals to 0, that means before inserting into that hemisphere when time is 0. So that is T5 temperature. When time is 0, it will be in degree centigrade. We have to convert into Kelvin. So we have now hemisphere temperature and test disk temperature. Next, either we have to plot a graph first, graph of test disk temperature, 0 second, 10 second, 20 second, 30 second. So time versus temperature, we have to plot a graph for test disk temperature, and we have to find out the slope of that graph. Otherwise, second method, we can calculate the slope of graph by the readings. So slope of graph, d of temperature divided by d of time, and with respect to t equals to 0. It means what? We note down T5 temperature for t equals to 50 seconds. So T5 temperature when t equals to 50 seconds minus T5 temperature when t equals to 0 second, and for this time is 50 seconds. So put the temperature T5 when time is 50 seconds, T5 when time is 0 divided by 50 seconds. Whatever be the value, it is nothing but the slope of that graph. And many times it is a human mistake that many students make a mistake to calculate the slope from the graph. So we prefer analytical method. So from this formula, we will find out what is the slope of this graph. That is d temperature divided by d of time. Fourth formula is heat gain by test disk. No doubt, heat is radiated by hemisphere black surface and it is received by test disk black surface. So test disk temperature will be rise. That means it gain the heat. How much heat it gain? So the formulas Q, heat gain by test disk, will be mass of test disk, Cp of test disk multiplied by change in temperature of test disk. So put the value, mass is given, Cp is given, dt by d of time already calculated in step 3. So we get the total heat gain by test disk. Now the final formula to find out the Stefan Boltzmann constant. So Stefan Boltzmann constant is equals to Q, that is total heat gain by test disk, divided by surface area multiplied by hemisphere temperature raised to the power 4 minus test disk temperature raised to the power 4. And this is 0.86 is a equipment correction factor. As this is the non-standard equipment, so itself in manual they provided that 0.86 is the equipment correction factor. So we have to use this factor also. So put the value of Q, put the value of A, put the value of TH, put the value of TD, TD at T equals to 0. So we get Stefan Boltzmann constant value. No doubt the standard is 5.667 and 10 raised to power minus 8. Our value will not come exact same, but it should be within a range. Next, result. So from our experimental finding, we have to put the result that Stefan Boltzmann constant sigma having this much value. Then the conclusion from the experimental data, it is concluded that the value of Stefan Boltzmann constant calculated experimentally, whatever be the value we find out, comes approximately same as that of the standard value. It is not exactly same, but come within a range. So we said it is come approximately same. So our experiment is successfully conducted. And the last, there will be a one graph. We have to plot a one graph. For graph, we will take temperature T5 only. T5 temperature is 0 second, 10 second, 20 second on y-axis, and time on x-axis. So variation in temperature on y-axis and time on x-axis. Now hereafter, we will move on to our experimental setup and then come back to our slide again. So this is our experimental setup. Stefan Boltzmann constant, we have to switch on it. Then always remember, before switch on your equipment, we have to check whether our overhead heating tank, this is the overhead heating tank. For the experiment purpose, I already heated it just 10 minutes before. This is thermocouple T6. This must be inserted in water always. Otherwise, we will not come to know what is the heated water temperature. There is one heating coil. As we switch on our equipment, there is no adjustment of voltage and current. Automatically, the power will supply to heater and heat will dissipate into the water and water start heating. And what is the water temperature? So we have to kept our temperature knob on 6. So it will showing this thermocouple temperature, T6 temperature. Now it is about 90 degrees centigrade. So there are 6 thermocouples, 1 to 4 thermocouples on hemisphere, 5th thermocouple on test dish, and 6th thermocouple is for water temperature. So at the beginning, we have to keep this knob on T6. So we come to know what is the water temperature. At least 90 degrees centigrade or more should be the water temperature. Then we will start our equipment. How to start? We will use this knob and allow this hot water to flow into this hemisphere. Once hemisphere get filled, the water level will be rise. We come to know that how much is the water. And then there is a one overflow hole is there. Once the water come outside from this hole, we have to switch off our this knob. So water flow will be stopped. On the bottom side, there is one hole, and this is a test disc. Wooden block, one copper disc is there, and thermocouple is inside. We have to insert this test disc into this hole, and then we have to note down the temperatures.
So our water is now about 95. We will switch off our heating power supply. Now we will allow this hot water to flow. As I said, handle this knob very slowly, so there will be no overflow. Water is going to fill in this hemisphere outer side. Once water will filled, we will observe the rise in level. Now the level is rises. And as soon as the water moving out from this overflow hole, we have to close the valve and stop this water flow supply. Now hot water is surrounded this hemisphere. Allow 2-3 seconds. Then after we will check out what is our temperature of hemisphere. So we will move on to T1. Then T2. T3. T4. So these 4 temperatures are mounted on hemisphere. Then after, as soon as I move on to T5, so this T5 temperature will be shown for this test disc, which is yet not inserted into this hemisphere. So this is 0 time T5. As soon as I insert this, I have to switch on stop clock, and after then I have to measure the temperatures. Temperature will be rise. T5 now 32.9. After 10 seconds, suppose 33.2. Next 10 seconds, 33.8. Next 10 seconds. Once 4 to 5 readings are noted down, then remove that test disc outside. Come back to initial position and switch off your experiment. Now we will go back to our slides.
Now we come to know how to measure the various temperature. In this only we have to measure the temperatures, correct? Remaining data is already provided in manual. And for the experiment, when I note down the readings, so I observe these readings, that is T1, T2, T3, T4. Only once we have to measure when our hemisphere is filled with hot water. So that readings are T1 is 86.8, T2 is 83.2, T3 is 86.1, T4 is 84.2. And before inserting test disc into that hemisphere, that is when time is 0 second, it is 34.2. Once I insert that phase disk into hemisphere, after 10 seconds I observe temperature is 40.5. Next 10 seconds 40.7. Next 10 seconds 42.2. After 40 seconds it is 43.4, and after 50 seconds 44.1. So I get a number of readings for T5. Use this table, calculate your Stefan Boltzmann constant, and that will be our experiment, end of our experiment. Okay.